Hello everyone. Today we are once again asked to calculate the blue area, that is this here. From here we are given that the area of triangle EQR is 200 centimeters squared. That is, the area of this triangle is 200 centimeters squared. We have the length of this side AB to be 10K, while this line BC is 8K. This line CD is not given. This angle here is a right angle, and here we see that angle PEQ minus angle QR equal to x. Here also we have 81 times 3 power x equal to 27 times 3. So how can we solve this? Starting from this equation, it says angle PEQ minus angle QER equal to x. This is angle PEQ and this is angle QER. So this angle minus this angle is x. Let's assume the size of this angle to be A and this B. So A minus B equal to x. But what is x? Here we have that 81 times 3 power x equal to 27 times 3. This 27 is 9 times 3. This 3 times this 3 is 9. 9 times 9 is 81. So 81 times 3 power x equal to 81. Divide both sides by 81. Here 81 cancels 81. While here 81 divided by 81 is 1. So 3 power x equal to 1. What is x? From this, we know that any number raised to the power 0 is 1. So 3 raised to the power 0 equal to 1. We replace this one with 3 raised to the power 0. So x equal to 3 power 0. In indices, we know if the bases are equal, the powers are also equal. That is, this x and this 0 are equal. So x equal to 0. We substitute here. Now a minus b equal to 0. Add b to both sides. Here minus b plus b is 0, while here 0 plus b is b. So a equal to b. That is, this a is b. Okay, now from this triangle ADE, this right angle proves that it is a right angle triangle. So we can use the Pythagorean theorem. The Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this here. So using the Pythagorean theorem, the square of this line AE must be equal to the sum of the squares of this line AD and this line DE. So line AE squared equal to line AD squared plus line DE squared. We subtract line AD squared from both sides. Here line AD squared minus line AD squared is 0. So line AE squared minus line AD squared equal to line DE squared. If we transposition, now line DE squared equal to line AE squared minus line AD squared. We keep it aside. Come to this triangle CDE. It is also a right angle triangle. So we use the Pythagorean theorem. This line CE is the hypotenuse. So by Pythagoras, the square of this line CE must be equal to the sum of the square of this line CD and this line DE. So line CE squared equal to line CD squared plus line DE squared. Bring line CD squared to the left hand side of the equation. So line CE squared minus line CD squared equal to line DE squared. Recall here we found line DE squared equal to line AE squared minus line AD squared. So we replace this line DE squared with line AE squared minus line AD squared. Now line CE squared minus line CD squared equal to line AE squared minus line AD squared. Take this line CE squared to the right hand side of the equation. So minus line CD squared equal to line AE squared minus line AD squared minus line CE squared. We take this minus line AD squared to the left. So minus line CD squared plus line AD squared equal to line AE squared minus line CE squared. Here minus line CD squared plus line AD squared is line AD squared minus line CD squared. So line AD squared minus line CD squared equal to line AE squared minus line CE squared. We keep it aside. Now come here, look at this line AD. It is a tangent to the circle at this point, while this line AE, this line BE, and this line CE are secants. Since all the secants are intersecting with this tangent AD, there is this theorem from the circle theory that if a secant and a tangent are drawn to a circle from the same external point, the product of the length of the secant and its external segment equals the square of the length of the tangent segments. So by this rule, since this secant AE and this tangent AD meet at this point, which is an external point to the circle, the length of this line AE times this line AP, which is the external segment, must be equal to the square of this line AD. So line AE times line AP equal to line AD squared. Line AE times line AP is line AE line AP. So line AE line AP equal to line AD squared, which if you transposition, line AD squared equal to line AE line AP. Come here, replace this line AD squared with line AE line AP. So line AE line AP minus line CD squared equal to line AE squared minus line CE squared. Come back here, this line CE is also a secant and this line CD is a tangent segment. So using the secant tangent theorem, this line CE times this line CR must be equal to the square of this line CD. So line CE times line CR equal to line CD squared. Line CE times line CR is line CE line CR. If you transposition, now line CD squared equal to line CE line CR. We come here, replace this line CD squared with line CE line CR. So line AE line AP minus line CE line CR equal to line AE squared minus line CE squared. Subtract line AE line AP from both sides. Here line AE line AP minus line AE line AP is 0. So minus line CE line CR equal to line AE squared minus line CE squared minus line AE line AP. Now add line CE squared to both sides. Here minus line CE squared plus line CE squared is 0, while here minus line CE line CR plus line CE squared is line CE squared minus line CE line CR. So line CE squared minus line CE line CR equal to line AE squared minus line AE line AP. From this line CE squared minus line CE line CR, we can factor out line CE. So it is line CE open bracket line CE minus line CR. And here we can factor out line AE. So it is line AE open bracket line AE minus line AP. Therefore, line CE open bracket line CE minus line CR equal to line AE open bracket line AE minus line AP. From line CE minus line CR, this is line CE and this is line CR. So line CR is a segment of line CE. That is, if we subtract line CR from line CE, we'll be left with this line ER. So line CE minus CR equal to line ER. That is, this line CE minus line CR is line ER. So line CE line ER equal to line AE open bracket line AE minus line AP. Now from line AE minus line AP, if we subtract this line AP from line AE, we'll have this line EP. So line AE minus line AP equal to line EP. That is, this line AE minus line AP is line EP. So line CE line ER equal to line AE line EP. Divide both sides by line EP. Here line EP cancels line EP. So line CE line ER over line EP equal to line AE. Now divide both sides by line CE. Here this line CE line ER divided by this line CE is line ER. So line ER over line EP equal to line AE over line CE. Now look at this triangle ACE. This line BE bisects this angle of 8. That is, it is an angle bisector of triangle ACE. There is the angle bisector theorem, which states that the angle bisector of a triangle divides the opposite sides into two segments that are in the same ratio as the two other sides of the triangle. So by the angle bisector theorem, this line AB, which is 10k, divided by this line BC, which is 8k, must be equal to this line AE divided by this line CE. So 10k over 8k equal to line AE over line CE. Here k cancels k. 10 is the same as 2 times 5, and 8 is 2 times 4. This 2 cancels this 2. So 5 over 4 equal to line AC over line CE. We come here, this line AE over line CE, we replace it with 5 over 4. So line ER over line EP equal to 5 over 4. We keep this aside. Now one of the formulas for calculating the area of a triangle is half the product of the length of two of its sides times the sine ratio of the angle between them. That is, the area of this triangle EQR can be calculated by the product of this side and this side multiplied by the sine of this angle. So area of triangle EQR equal to 1 over 2 line EQ line ER sine B. Recall the area of triangle EQR we were given here to be 200 centimeters squared. So therefore 200 centimeters squared equal to 1 over 2 line EQ line ER sine B. Now look at this triangle here. Its area can be calculated by half the product of this side EP and this side EQ times the sine of this angle B. So area of triangle EPQ equal to 1 over 2 line EP line EQ sine B. Divide this equation by this. So 200 centimeters squared over area of triangle EPQ equal to 1 over 2 line EQ line ER sine B over 1 over 2 line EP line EQ sine B. Here this 1 over 2 goes with this 1 over 2. This line EQ eliminates this line EQ, and this sine B cancels this sine B. So 200 centimeters squared over area of triangle EPQ equal to line ER over line EP. Recall here, line ER over line EP equal to 5 over 4. That is, this line ER over line EP is 5 over 4. So 200 centimeters squared over area of triangle EPQ equal to 5 over 4. Cross multiplying now, 200 centimeters squared times 4 equal to 5 times area of triangle EPQ. Here 200 centimeters squared is the same as 20 times 10 centimeters squared. 20 is 5 times 4. 4 times 10 centimeters squared is 40 centimeters squared. 40 centimeters squared times 4 is 160 centimeters squared. So 5 times 160 centimeters squared equal to 5 times area of triangle EPQ. This 5 cancels this 5. So 160 centimeters squared equal to area of triangle EPQ. That is, the area of this triangle, which is the blue area we are asked to calculate, is 160 centimeters squared. Thank you for watching. Please like, share and subscribe, and also turn on notifications. Thank you.